In this video, we're going to go into more detail about what ions are, how they form, and how we can use ions in order to understand more about how compounds form. Now, even before we talk about ions, we're going to do a little bit of review of Bohr-Rutherford structural drawings of atoms using sodium and chlorine, the reasons for which will become obvious in a second. So first we need to figure out the number of protons for each of these, which is easy. We just take a look at the atomic number. Sodium has 11 protons and chlorine has 17 protons as the atomic number shows. So I'm just going to write that number in each of their nuclei. We can put the chemical symbol in next. So sodium is chemical symbol Na and chlorine is chemical symbol Cl. Next, we can round each of the atomic masses. So 22.99 rounds up to 23. Let's write that properly. And then from that, we can subtract the atomic number to find the number of neutrons. So 23 minus 11 comes to an even 12. So that means that sodium has 12 neutrons. And we know that this is correct because 12 plus 11 gets us back to 23, which is the atomic mass of sodium. If we do this with chlorine, 35.45, we would round down to 35, and from that we would subtract 17, the number of protons, to find that chlorine has 18 neutrons. Now the final stage is to put the electrons in. So remember that the atomic number also tells us the number of electrons. So if we do sodium's first, we add 2 electrons that are paired in the first shell, and that means that we have 9 electrons remaining. Then we add the first 4 in the second shell like this, and now we can start to pair them. So that means after we have added all 8 or 4 pairs of electrons in the second shell, 9 minus 8 means that we only have 1 electron remaining, which we can put in the third shell like this. Now with chlorine, because there are 17 electrons, we start the same way. We add the first 2 into the first shell, meaning that we have 15 left. Then we add the first 4 into the second shell, and now that we've added all 4, we can start to pair. So now we've added the next 8 electrons into the second shell, so 15 minus 8 means that we have 7 electrons remaining. So now we need to be careful about not pairing electrons until we have to. There's the first 4. Now that means we only have 3 electrons remaining. And after we do that, we can see that we have 3 pairs of electrons with 1 unpaired electron. I'm just going to write that here, that this electron is unpaired, and that means that we now have 0 electrons, and both of our starting Bohr diagrams are done. Now remember that ions form whenever the valence shell, and remember that the valence shell is always the outermost shell of an atomic structure that contains an electron. So we don't count any of the empty shells outside of the third shell for either element. We can see that sodium has 1 valence electron, 1 electron in its third shell, while chlorine has a total of 7 valence electrons, 7 electrons in its outer shell. Now, ions form when the valence shell, whichever one the outer shell is, becomes full of electrons. So remember that in the third shell, in both cases, a full valence shell would correspond to 8 valence electrons. Now, I'm going to make a little note here. We can say that a valence shell becoming full or a valence shell becoming empty, in quotes, results in the formation of an ion. Now, in the case of chlorine, it's actually easier to understand how the ion forms, because if chlorine has 7 valence electrons and 8 electrons is full, all we need to do is add 1 more electron, and now its valence shell, because of the fact that we added 1 and has 8 valence electrons, now we can say that it is full. Now, there are two ways that we can analyze this. One is actually by doing a complete charge calculation, where we take all of the protons, which is 17, and we know that each proton has a charge of positive 1, so 17 times positive 1 is positive 17, because it's the same thing as multiplying by 1. Then, if we look at the electrons, normally the number of electrons would be the same, but remember that we added 1 here. So if we have 18 electrons, and each electron has a charge of negative 1, that means that the total charge of all of the electrons is negative 18. Now, if we add these two numbers together, the total positive charge from all of the protons and the total negative charge from all of the electrons, positive 17 minus 18 gives us negative 1. This shows us that ions are a form of an atom that exists when the atom's valence shell becomes full, which causes them to have electrical charge because their numbers of protons and electrons are no longer equal. If you've done this charge calculation right, you should find that the charge matches the indicated charge on the periodic table, and to indicate using the chemical symbol that we have an ion, we can write Cl- with the negative 1 charge that matches. Now, if we do this with sodium, if we were to add valence electrons to make its valence shell full, we would need to add 7 valence electrons, but that seems a little bit strange considering chlorine only added 1. Now, this is where we use this little hint here, where we can see that it's possible to get a full valence shell when the outermost shell becomes empty. So instead of gaining 7 electrons, what we can do here is we can lose this 1 electron instead. Now, this seems like relative common sense. Losing 1 is much easier than gaining 7 because you need to do a lot less in order to lose 1 compared to gaining 7. So that's exactly what we're going to do. We're going to say that sodium loses its valence electron, which means this shell is now, I can spell, I swear, is now empty, which means that we don't even need to consider this shell anymore, which means the second shell is our new valence shell, and we can see that we have 8 electrons there. Now, if we do a charge calculation of sodium, we can see that sodium has 11 protons. 11 protons times positive 1 is positive 11. That's the total charge of all of the protons in its nucleus. But because sodium lost 1 of its electrons, now we only have 10 electrons in its shells, and 10 times negative 1 is negative 10, and if we do positive 11 minus 10, we end up with positive 1, showing that sodium as an ion, because it has lost an electron, actually has positive charge, and we can see it lines up exactly with the positive charge that is indicated on its periodic table entry. And if we wanted to indicate this with its chemical symbol, we would write the element symbol Na and then put a plus sign in the top right to indicate that its charge is positive 1. Now, from what we can see from the color scheme, we recognize that chlorine is a nonmetal while sodium is a metal. And you can see this if you look at their entries on the periodic table. Now, the general trend or the general pattern that we can see is that nonmetals such as chlorine gain electrons rather than lose electrons, which makes them negatively charged ions, which are what we call anions. Let me write that more clearly. Anions. While metals such as sodium, because they have a fewer number of electrons or a smaller number of electrons in their original valence shell, it is much easier for them to lose electrons, in which case they would become positively charged ions, which are what we call cations. In part 2 of this video, we're going to look at a couple of elements that do not actually form ions the way that sodium and chlorine do, as well as take a look at the importance of understanding what charge atoms form when they become ions.